Good morning and welcome to you all. In this particular class, we are going to study all the important rules with examples to solve the IUPAC nomenclature of coordination compound. Guys, before going to this rules, we should know that in a general structure of a coordination compound, we are always going to find a bigger bracket which is known as coordination pair. In front of coordination pair, always the cation do lie. When we enter the coordination pair, we are going to get the metal, and rest all the species other than that of this metal are termed as ligands. When we end with this coordination pair, then comes an anion. Okay. Okay, so here are some rules or the key points which is to be known to us, otherwise we are not able to do the nomenclature question properly. First rule states that in case of IUPAC nomenclature of an coordination compound, the IUPAC name of that compound do carry five of the terminology. Number one is C, then comes L, then comes M, then O, and then A. In Hindi we can say it is kalmuha. ठीक है कलमुआ ठीक है C for cation, L for ligand, M for metal, O for oxidation number, and A for anion. And remember that while naming while giving the IUPAC name of a coordination compound, the name should carry the sequence only, otherwise your name will be considered to be incorrect one. Okay, that is the name do follow the sequence: kalmua, cation, ligand, metal, oxidation number, and anion. Okay, now going towards the second point, we came to know that when the name of the ligand is been given, in case the cation and anion are more than one in number, then their number will not be mentioned. Say as if in this particular example Cl is 3, we are not going to write trichloride. We will write only chloride. Do you get it? That means in case the cation, that is front one, and anion, that is the backward pole components, are more than one in number, then their number will not be mentioned. Okay. Next point states that the oxidation number will always be represented in bracket in Roman digit. Always the oxidation number should be calculated as our name to carry O means oxidation number. It should be mentioned in Roman digits, that too in bracket. Okay, moreover, if the number of the ligands is been more than one, then we will be preferring di, tri, tetra, penta terminologies. Meanwhile, in case of bulky ligand like EN, ethylene diamine, DMG, C5H5, etc., the number is being represented as bis, tris, tetrakis, etc. Okay? That means if ligands are more in number, generally they are represented as di, tri, tetra, penta, etc. For the bulky ligand like this, we are going to write bis, tris, tetrakis, etc. Okay? And that too in front of the bracket. Okay, next terminology states that, next rule states that if more than one type of ligands are there, that is in case of mixed ligand, which has been explained there in the last class. In case of mixed ligand, we should follow the alphabetical sequence. That is, if an ligand do contain H2O, that means aqua, and a ligand do contain Cl, that is chloride. Therefore, we can say that aqua A and chloride is C. Therefore, aqua being by following the alphabetical sequence, the aqua should come first and chloride should come at back. The last point states that in case of anionic complex, that is, we do have a cation in front of the complex. In that particular case, the metal's name will end with 8. That is, if it is iron, it will be known as ferrate. Chromium, if it is chromium, then the name of metal will end with chromate, like this. Okay. So this whole 4 points will be more clear when we are going towards these examples. Okay. So we are moving towards the example. Number one example I had preferred over here is cationic complex. We can say why this complex has been termed as cationic complex, because if I take this complex and place there in the water, I'm going to cleave the compound like this. My whole complex will carry which charge? Positive charge, as Cl will acquire the negative charge. Okay, that is already taught you to it there in the Wiener theory zone. Okay, Back to IUPAC nomenclature. If you got any of this type of cationic complex, firstly what you are going to do, you will be calculating the oxidation number. Let's see the oxidation number. As I already told, that oxidation number is being calculated for the central metal atom itself, so it is being considered as X over here. NH3 is a neutral ligand, therefore its oxidation number is 0. Number of NH3 is 6, that is 6 into 0 ho jayega. Thereafter what we are going to see, that the Cl is a anionic compound and do have an oxidation number of -1. Cl is 3 in number, therefore 3 into -1, that is minus ka 3. Whole complex do not carry any of the charge, therefore after equal to we are going to place a 0 over here. -3 when moves over on the other side, we are going to get X is equal to plus ka 3. So the oxidation number of CO comes out to what? Plus ka 3. Okay, now we are moving towards the IUPAC nomenclature. What I say? Kalmoa, CLMOA. But it's remarkable that we don't have any cation over here. So I am crossing this cation. Then we are moving towards the ligand. Ligands are NH3, which is 6 in number. 6 means hexa. NH3 means amine. Then comes CO. After writing the ligand, we are moving towards metal. That is CO, which is what? Cobalt. Then O means oxidation number. That is 3 over here. We will write the oxidation number in Roman digits. That's 3 in bracket. And what we are having? Cl, which is chloride. Although it is 3 in number, we are not going to mention the number of it. We will write what? Chloride itself. Okay, in the second example, I had preferred a mixed complex over here because different type of ligand is being used in this particular example. First step, we are going to calculate the oxidation number of chromium, that is X, plus oxidation number of H2O is equal to 0, 4 into 0, plus oxidation number of Cl is equal to -1. How many Cl? 2, therefore 2 into -1. And NO3 do have an oxidation number of -1. The whole complex do not carry any charge, therefore equal to and 0 has been placed. So 4 into 0 is 0, -2 and -1, that is minus ka 3. When goes on the either side, we are going to get the X value to be plus ka 3. Okay, again CLMOA, Kalmoa. We don't have cation over here, so we missed it. Then we are going to think about the ligand, but as we do have two different type of ligand, we are going to follow the alphabetical sequence. H2O means aqua, Cl means chloride. Do remember that we are not going to see this tetra and di. Mainly when this nomenclature is being done by students, they say that ma'am, in tetra T is coming and di D is coming, so we should write dichloro in front and tetra aqua at back. That is wrong. We are not taking care of this di, tri, tetra, anything. We are considering our ligand only, that is ligand carry aqua A and chloride C. So as A for apple comes first, therefore tetra aqua will come first and then comes the dichlorido. Do remember, as it is ligand over here, so we are going to write the chlorido terminology. So we are going to get tetra aqua dichlorido. Okay, now this is Cr. Cr means chromium. Okay, then we do have finished our ligand. We have finished with metal. Then comes the oxidation number, which is 3 bracket. We are going to write 3, and then NO3. NO3 is a nitrate component over here. Okay, probably I feel that you are done with this cationic complex. One more example has been taken over here. Let's see it also. This is CO, Cl2, En2, SO4. Again, firstly we have to calculate the oxidation number. CO, that is your cobalt, we have to calculate, therefore oxidation number is X over here. Then plus 2 Cl 2 in number, but oxidation number of 1 Cl is equal to -1, therefore 2 into -1, and plus ethylene diamine is a neutral ligand, so do not have any charge, that is its charge comes out to 0. 2 into 0 plus sulfate is equal to -2. Whole complex do not carry any charge, therefore we are going to get equal to, after equal to we are placing 0. Okay, that is -2 and -2. We are going to get the -4. We are bringing the -4 on opposite side, so we are going to get X is equal to plus ka 4. Okay, after calculating the oxidation number, now we are ready to write the name of this compound. That is again what? Kalmuha. But we can see that C is not here, so C is being cancelled out. Then L, ligand, two different type of ligand, En, ethane 1,2-diamine, and Cl, chlorido. So E and C will come first, therefore chlorido will come first. It is 2 in number, therefore dichlorido. But En is a bulky ligand, so instead of ethane 1,2-diamine, we are going to write what? Bis. Ethane 1,2-diamine. Coordination bracket is being closed. That is, name of ligand is over. We are moving towards metal. CO means cobalt. Then O means oxidation number. In bracket we are going to write 4 in Roman digits. Then SO4, that is sulfate. Okay. Next, we had completed with the cationic complex. Again we are going towards the next one, that is anionic complex. Let's see the examples. Okay, K3FeC2O4 whole thrice. First step, we are going to calculate the oxidation number. Again, we K3, that is potassium, is having an oxidation number of plus ka 1, and it is 3 number, therefore 3 into plus 1. Iron we have to calculate, therefore I am placing an X over here. Oxalate do have an oxidation number of -2, therefore 3 into -2 is equal to whole complex to carry 0 charge is equal to 0. Therefore 3 into 1 plus ka 3, 3 2s are 6, -6. When we cancel out, it is -3, and when it goes to on the opposite side, we are going to get X is equal to +3. Done. Okay, next we are going to write the name. What is the strategy? We should have the sequence Kalmua, CLMOA. Okay, we can see that in this particular name we don't have A, anion is missing. So we are going to start with the C. The C means K, that is our potassium. Whether it is 3 in number, it is not matter to us. Whether it is 3, 10, anything, the number should not be mentioned. Therefore, it is potassium. Then comes L, ligand, C2O4, it is oxalate, and so the name comes out to what? Oxalato. Okay, it is 3, therefore trioxalato. Now Fe is having +3 charge, therefore it is, and moreover as it is anionic complex, so the name turns out to what? Ferrate. Okay, and at last we are going to place the oxidation number, which comes out to what? 3, therefore in Roman digit we are placing a 3 over here. In this next example, again it is also an example of an anionic complex. We are going to calculate the oxidation number 1, oxidation number first. Therefore again ClR3, therefore 3. Potassium do an oxidation number of +1, therefore +1 is written over here. Cobalt's oxidation number is being calculated, therefore I am placing an X over here. Cn do have an oxidation number of -1, and Cn are 5 in number, that is 5 into -1, plus NO, nitrosyl group is a neutral ligand, therefore it is having a charge of 0. After equal to, as a whole complex do not carry any charge, so we are going to place a 0 over here. When we solve this, we are going to get the value of X is 2 plus ka 1. Okay, now again Kalmua, C, that is potassium. Okay, L, ligand, we are having two type of ligand, that is it is cyano and it is nitrosyl. In cyano, C comes first, therefore we are writing C, cyano, but it is 5 in number, so we are writing pentacyano. Then comes NO, that is nitrosyl. Okay, ligands are over. Then comes what? Metal. Metal minus CO is equal to cobalt, but we do this is an anionic complex, so the name will end set to what? Cobaltate, and the whole complex is carrying two oxidation numbers, so we are going to write a charge of oxidation number of 2 in Roman digits. Okay, with this we have finished up with the anionic complex. Last, towards the non-ionic complex. Okay, in this particular example, NiCO4, this is a non-ionic complex. Again, in first step we are going to calculate a non-ionic complex means what? We don't have any cation, neither we do have any anions. In this complex is been termed as non-ionic complex. Okay, first step we are going to calculate the oxidation number. Again, and nickel's oxidation number is being placed at to be the X plus CO is 4 in number, therefore 4, but oxidation number of CO is equal to 0, therefore 4 into 0. This whole complex do not carry any charge, therefore we are writing a 0 over here. So the value of X comes out to what? 0. Okay, now कल मुआ C cation is not there, then we are moving towards what? L mane ligand. Okay, we do have 4CO. 4 means tetra, CO means carbonyl. Okay, tetra carbonyl. Ligand is over, then we are moving towards the metal. Nickel is over here, nickel, and as it is not an anionic complex, therefore the simple nickel will come. Okay, now oxidation number is what? 0, so we are going to write a 0 over here. Next, the last question of today is Ni DMG whole twice. Okay, DMG is a bulky ligand, so in first step we are going to calculate what? The oxidation number. Nickel's oxidation number is to be calculated, therefore X plus DMG is 2 in number. 2 1 DMG has an oxidation number of -1, therefore 2 into -1 is equal to 0. X value comes out to what? 2. Okay, now okay, in this particular thing, DMG is a bulky ligand for therefore, and it is 2 in number. For 2 we are writing bis DMG dimethyl glyoxymeto. Okay, in bracket we are writing this, bracket close, then ligand is over, then comes what? Metal is nickel over here, and then O for oxidation number, it is 2, as an ion is not there, so the name comes to an end. Okay, I hope with this you are cleared with this IUPAC nomenclature of coordination compounds. For further difficulties, we will be coming in the line, we will be clearing the difficulties there in the live session itself. Okay, till then, bye bye guys, stay tuned with me.